my name is Beata Kalisz Hedegaard and I lead QuantumPrime. And our mission is to provide secure satellite communication and data exchange utilizing quantum entanglement. So we are addressing the vulnerability of terrestrial but also satellite communication systems that are susceptible to eavesdropping and hacking. And that can lead to a leakage of sensitive data, and that can lead to compromising national security or posing a risk to personal privacy or corporate secrets. And that will only intensify in the future where we have quantum computer-enabled hacking. So we are aiming to build a solution, a hardware and software solution that can be put on satellites, but also on the ground stations to enable the links, quantum links between the satellite and the ground station, but also between the satellites. So our customers will have a device that provides an entanglement. We are designing a solution that will both have the detection and production of entanglement. And this way, our customer can provide a service, for example, such as using the classical link from the satellites that do not have such a quantum modules on to relay. In the first stage, we would like to encrypt it with quantum key distribution based on entanglement, but later on we could do actually a teleportation of data to the quantum computers. So you can think about it that it's a limitless possibilities when one invests into entanglement as a service. Because you could do that, as I say, quantum key distribution from the satellite to ground stations, but you could also have it as a repeater, and you could actually teleport data between two quantum computers on Earth. And that's still the same technology. Then further, you can provide distributed sensing and distributed computing, not only for the terrestrials, but since the equipment would be in space, you can actually do quantum distributed sensing, taking advantage of the in-orbit infrastructure. Our goal is to aim for a new space that puts actually a lot of satellites in on the constellations, and collaborate with big space primes on larger satellites. But we see that this type of equipment could be put on a smaller or lower stages for airplanes, drones, and so on. So it's the market opportunity, it's huge, and there is a forecast that quantum communication hardware will reach €1 billion by 2034. The global cybersecurity, it's 40 billion by 2030. And sorry, there is a typo, but the global space industry might increase to more than 10, well, American predictions actually are that it's 1 trillion by 2030, but Chinese prognosis says about up to 10 trillion on the space sector, and we are fully embedded in this amazing market opportunity. So our business model is based on the sales of the hardware and software, we see it as there's going to be sales of various generation and going to eventually going to a full support of the multi-protocol infrastructure. On top of that, we see ourselves as a consultants and want to collaborate on the feasibility studies and support our clients that design the satellite-based communication networks on the already emulation and design stage, but also later on a pilot and deployment stage. So I am a quantum physicist. I have a degree in quantum physics. I have a second master degree in nanoscience. I have a lot of experience with data simulations. I have education in electronics and telecommunication and worked in various labs in optical systems and building radars. I also have experience with entrepreneuring, and I've worked also as a patent engineer. My co-founder, Paweł Grudziński, has many years as a space system engineer and designer of electronic and optical systems specifically for space, and work also on telecommunication satellites and design and testing modules for space. Our vision is to become the leading provider of entanglement as a service through the secure satellite-based infrastructure for Earth and beyond. We want to contribute to building a quantum internet. We see that entanglement as a service is the future for pushing our civilization to the next stage when we can do inter-celestial communication. Thank you very much.
Thank you, Anna Beata. So, Anka, you want to go ahead?
Sure. Thank you for the presentation. It's very inspirational what you are doing, but my question is, how did you validate either of your products, or where are you in the development stage?
So we validated the idea, the concept and architectures. We are in a constant talks with Airbus, Space and Defense in Bremen. So we are situated in Bremen. We started actually talks now with OHB. They are highly interested, and we are talking in defining different services. So there's going to be a Eagle one going. There's constantly postponed, but hopefully in 2026. That's what I heard last time I talked with people. But there's going to be also Saga. Saga will be actually doing entanglement. I hope so. It's all confidential. But in principle, we want to work with them to define the services of the future that will be enabled by that type of technology. And they are on the first stage. We're talking also with DLR, that could also be our customer. And there we're actually talking about further exploring the design of teleportation from the satellite to two quantum computers and building links. There is no doubt that there's going to be market for the entanglement as a service. The same says Nokia. We have a good feedback from everyone. The question is when.
Can I answer?
Thank you. Sure.
Okay, so what stops SpaceX from developing this technology before you are done validating and start building? What's your uniqueness?
I don't know what SpaceX is doing, but they're pretty busy doing the launches, and that's complicated enough. Nobody is being stopped from doing what I'm doing, but there is not competition. I don't see it around people tackling that. It takes to be a bit of crazy, I would say, at this stage. But it has to be done right now, okay? It takes time to put something like that in space, and when I talk with people that actually have experience, been doing space for 20 years, they say, you're right, we need to get started right now.
Thank you. I think it's an interesting technology, and I always like when it intersects very cool topics. I have one question is, it's going to be a tough market because obviously when you look at, for crypto only, PQC is still very much good enough for a lot of applications, you know, to encrypt. But I do see a market, however, for connecting quantum computers in the long term, because we understand that going through classical states, you know what I mean, from quantum to classical to quantum is not very efficient. What is the type of bandwidth you could achieve if it's not just PQC, which is low bandwidth? You just need to send a few limited number of information. But let's say if you want to send really information from the ground to a satellite that is more, you know, with more data than just QKD, type of applications.
I don't understand the question in the
For QKD, you don't need to send a lot of data. You need to send a few thousand bits. That's all you need to send, right?
Yes, that's right.
But let's say now
that's
you
why
want...
we want to start with quantum key distribution.
Yeah, exactly. But in the long term, I do see a market to connect quantum computers together. And I was wondering if you can achieve if you can send, what is the type of bandwidth you could achieve with the technology, the type of, you know, the information you can send, the quantity of information. Is it limited, or is it, what you can do with the technology?
It's constantly developing. We're talking about the technology that is new, and there is no precedence of putting quantum teleportation on a satellite and building internet in space. I would say it will develop with miniaturization of quantum computers. You need quantum memories. I'm all the time on a look for a new tech that will enable it. Now, at the moment, we're doing deterministic production of entanglement, but there is a deterministic quantum dot sources. I think they have an amazing potential because you have one technology that could provide all of the aspects, and in principle they could work in space. So I already looked on those systems, and it looks very promising. And since it's a long run, that's why I say there's going to be many generations of hardware, and I see myself more as an integrator that defines the requirements to build that type of network in collaborations with even bigger players like Airbus, that later on actually is the integrator for the gold space. So we have a mentor in space industry that we get a lot of feedbacks to. We are a small team, we are starting, but we are highly supported by a lot of people.
Thank you.
Thank you, Anna Beata.